advanced math. On to a big brand new topic today. We started the year doing sort of calculation, a lot of just traditional math, fractions, decimals, all that. Then we moved on to unit item ratios and rates. And then after that, we spent the last about 6 weeks working with variables, expressions, equations, inequalities with variables. We're going to totally go on to another branch of math called geometry now, which is sort of shapes and figures. So our first lesson on that today is going to be finding the area of right triangles and parallelograms. So if you want to do a whole new section for geometry, that's fine. And our first topic will be finding the area of right triangles and parallelograms. So speaking of area, let me take you back to 4th grade. We talked about area. So we always talked about the area of rectangles in 4th grade. And we had 2 ways to find area. One was if we can look at our rectangle like this and say, okay, it's across the top, it's 1, 2, 3, 4, 5 and a half units that way. And 1, 2, 3, 4, 5, 6, 7, looks like 8 that way. And our so area is the space inside of a figure. How many, and it's usually measured in square units of some kind, square feet, square miles, something like that. And so we're looking at like how much space is inside of this rectangle is what area is, in case you've forgotten that since 4th grade. And so one of our strategies for finding area in a rectangle 4th grade was just to count the squares and say, this is going to be, there's going to be 8 this way and 5 this way. So not counting these little half ones, there's going to be 40 squares here. And then these are halves, so there's like 1 more, 2 more, 3 more, 4 more, so there's 4 more squares there. And so altogether, if we counted the squares, there'd be 44 square whatever, square units here, square feet, square inches, something like that. So one way was just to we call it tile it into squares and count the squares. Sometimes that got to be inconvenient. It's like if I had, if I gave you a rectangle like this and said, we'll find the area of this rectangle, like nobody wants to draw 35 and apart squares and then 12, and how do you even draw 8/10 of a square and then count all the squares? So we had another way, which was to just use a formula. And we said 2 ways we wrote the formula. One was area equals the length times the width. So we would maybe call this the length and this the width. Or sometimes we called it area is base times height. So like base is like the side that it's sitting on. So I would say that its base is 35 and 25 hundredths feet here, multiplied by the height, like it's standing up, and it's 12 and 8/10 feet tall, and then multiply those. And so that was a lot faster than tiling, especially now that you're calculator people. So if I drew all those squares, there'd be 451 and 2/10 of a square. So we'd say, inside would be 451 and 2/10 square feet in there. If I drew all those squares, which I'm not going to do. So formula was a strategy and tiling was a strategy. So we're going to move on to some shapes that are not rectangles here in 6th grade. So I'm going to start with a right triangle. So let's say I needed to find the area of this right triangle here that I have drawn. So what gets tough about that is, like, I drew it on graph paper so we could try the tiling strategy, but if you look, counting tiles is not going to be very easy on this because, say right here, I don't know, is that 1/3 of that square? Is that 1/4 of that square, 1/5? It's hard to tell exactly what part of a square like this is. Is that 1/10, 2/10? I don't know. So tiling, I can't just look in here and count tiles. And the base times height formula is great, except that is for rectangles. It's not for triangles. So I can't use that either because I'm gonna, if I tried that, if you even look here, this is 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6, 7, 8, 9. So 4 times 9, base times height is 36. There are not 36 square units in here. mean, if I count just the whole ones, 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13 whole ones, and then some parts, there's no way I'm getting up to 36 whole squares. So that formula is great for rectangles, but does not work for triangles. So I want to show you a cool trick to figure out how many square units are in this rectangle. So check this out. What you can do with a right triangle is, if I were to imagine, I can, what I call double it. Like, I can think about turning this rectangle, or turning this right triangle into a rectangle. And the reason I would do that is that finding the area of rectangles is super easy, because I've got the formula, or I can count tiles. Because now if you ignore this part through the middle here, there are 1, 2, 3, 4 this way by 9 this way, which means if I counted them all up, as I already did, or use the formula, I know that this rectangle has an area of 36. And if I know that that rectangle has an area of 36, well, this cuts it in half. This rectangle, there's half here and there's half here. So I could say, well, if I just want to look at this part, just my triangle, how much space is in there? Well, if the whole rectangle has 36, then my triangle has half of that. Just divide that 36 by 2, and it would have 18 full squares in there. So what I do to find the area of a right triangle is I double it, find the area of the whole rectangle, and then divide it in half. Cool? So now if I added all these little parts together, I counted 13 whole ones, and if I added all these little parts together, there would be 5 more, and so I would have an area of 18. Pretty neat. We'll do one together in a moment. So that's one type of figure you may find the area of, other than a rectangle. The other is a parallelogram. I'll show you a parallelogram here. So I've also made one of those for the ladybug. I'm going to show you a different strategy on this. So now let's think about finding the area of this figure. This is called a parallelogram. Parallelograms have 2 sets of parallel sides. These sides are parallel to each other, and these sides are parallel to each other. If you extended them, they would never intersect. Now, I run into the same issue I ran into with the triangle. If I try to look here, I can't tell, I can't just tile it. I can't tell, like, this is almost a whole square, but not a whole one, and I don't know how much is cut off there. Same with this. And so I can't exactly count these by tiling. But same thing with the right triangle. So what I can do is I can turn the parallelogram into a rectangle. So what I did with the right triangle is I doubled it and I turned it into a parallelogram, or into a rectangle. I'm going to do the same with this. So I actually cut this out because this one's easier to tell what's going on now that it's cut out. So check out what I'm going to do. I'm going to take some scissors. I'm going to cut a triangle off of here, right there. And if I move that to the other side, look what I have. I have a rectangle. And this is super easy to find the area of. 1, 2, 3, 4, 5, 6, 7 by 1, 2, 3, 4, 5. So the area of this rectangle would be 35 square units, which means the area of the parallelogram is the same, because look, I don't change how much space is in my figure by turning it back into a parallelogram. There's the same amount of space in it, the same amount of squares, I just move them. So I can turn this into a rectangle because it's easy to find the area of that, even though it's hard to find the area of that. So this had an area of 35 square units, and so does this. There's really no difference. So that's how you can find the area of a parallelogram by turning it into a rectangle. So I want us to do one example of each of these together. So let's do that. So open your notebook now. So here's a right triangle one to do. So it says Amy wants to paint the side of a ramp she built. How many square feet of surface will she have to paint? So remember, area, I don't need this anymore. Close that. Area is like she's going to paint it, right? It's the area inside. So oops, I'm not going to be very good at doing this with my mouse. So So like imagine she's going to paint the side of this ramp. You know, how much space is inside the ramp? So my strategy for a right triangle is going to be double it into a rectangle. Find the area of the rectangle and then divide it by 2. So what I'm going to do, I'm going to take this right triangle, and I'm even just going to draw it. I'm going to draw a clone of this right triangle like this. Right, now I have the exact same right triangle here and here. And this is pretty easy to find the area of, right? Because I can just look at this rectangle and say, okay, well this is 8 7/10 feet this way by 2 6/10 feet this way. All I have to do is base times height and find that. So 8 7/10 times 2 6/10 is, the whole rectangle is 22 62/100 square feet. The whole thing. So if that whole thing is 22 62/100, this triangle I'm looking at, that's half of the rectangle. So all I have to do now, double it, find the area of the rectangle, and then just divide it by 2. Divide by 2. And so just my rectangle had an area of 11 31/100 square feet. So that's how much paint you'll need. That's how you do a right triangle. Double it, find the area of the rectangle, divide it by 2. Let's also do together a parallelogram. So here we go. So a lot of area problems involve chicken coops. I don't know why. So imagine this is like a big 12.5 feet by 7 feet chicken coop. And the chickens are just going to run around in here. I'll say, how much space will the chickens have to run around in this weird shaped chicken coop? So I've drawn all the measurements on here. 12.5 feet this way, 7 feet this way, and sorry, my phone's ringing. Turn that off. And so what I want to do with a parallelogram, different steps. So all I really want to do is move one triangle across, which will turn it into a rectangle with the same area. I don't have to do any dividing on this one. So what you want to imagine doing is I want to take this triangle right here and move it over here, because it'll fit perfectly here. And then if you do that, you have a rectangle. You have a 5 feet this way by 12.5 feet this way rectangle. It's exactly the same amount of space. I just moved this piece across from there to there. And I can just say now, well, area of a rectangle is the base times the height. So one thing to be careful of, notice this 7 feet thing, this actually doesn't matter. This is 12.5 feet across and 5 feet up. And this actually, well, that's how long that is, that doesn't actually matter. So now I've just got to do 12.5 feet times 5 feet. And so the whole thing has an area of 62.5 square feet. So even though I made a new figure out of it, if this is 62.5 square feet, if I move that piece back over there, I still have the exact same amount of space inside. It doesn't really change my actual figure. All right? So all I do is I just take this and move it over there. So I'm going to go ahead. If you need to go back and pause when I had the figure drawn there, please do that. So this is kind of a hard concept, but our first strategy on area is turning things into rectangles, because rectangles are very easy to